Alright, so if you've ever wanted to make Honkai star rail renders and animations in Blender that look like in-game, well, boy do I have the shader for you. It's called Stellar Tune and it's for Goo Engine 3.6.1 at the time of this video. What you're seeing right now is a demo file set up by Isaac and me. He made the rig itself and then I set up Stell with the shader. And as you can see, everything works as is. The phase shading, the light direction, it's all in real time, including the outlines that scale with the camera distance, and also the rim light, which, why is it thick right now? Whatever. If you want the demo file for yourself, you can use it for your animating needs, or just to dissect the rig or the shader. You can do just that. I'm going to be linking it in the description below. So let's get started. The first thing you need is the shader itself. So if you head to this GitHub page right here, what you can do is you can either clone it with git in command prompt, or you can head to this web page right here, click on stellartune.blend, and then click on the download file. I already have it downloaded, but you need to do that if you want the shader itself, obviously. And then the second prerequisite, the second thing you'll need is a paid add-on, which you can get somewhere else, wink wink. It's Better FBX Importer, and we will be needing this unfortunately because how Blender's default FBX importer works is it's pretty much reverse engineering the FBX format, and obviously like that's just not gonna work for star rail models. They have some special data within them that the FBX importer cannot import, and with Better FBX Importer, it uses the SDK itself and it will just yield better results. It's guaranteed to yield better results because it uses the SDK. The third prerequisite is another paid program. Technically it's not paid. If you can compile it by yourself, the source code is available on GitHub. If you can compile it by yourself or have a friend compile it for you, then it's technically free. But if you can't do that, unfortunately, I believe you'll have to subscribe to their Patreon just to get the program pre-compiled for you. It's $5, so you might as well support them if you want, but I'm just saying the option is there if you want it for free. Why Goo Engine specifically? There are a couple of features that vanilla Blender doesn't have, and we're basically using all those features in Goo Engine, especially this see-through effect on the eyes. The rim light as well uses a custom node that only Goo Engine has. The fourth thing you'll need is the set of files for your given character. In our case, it's gonna be Pela, and with each character comes an FBX file, the texture files, and then the material files. Unfortunately, I will not be able to give you guys directions on where to go. If you want these files, you can either learn how to data mine or you can look them up on Google. So, on a fresh Blender scene, we'll delete everything. We'll import our character with Better FBX Importer. For the import settings, we want the rotation to be XYZ Euler. The scale should be 0.01. Reset Mesh Origin should be unticked. Fix Attributes should be unticked. And Edge Options should be Generate by Blender. So nothing may have seemed to have happened, but that is not the case. We can always just reset the scale by clicking on the empty, pressing Alt plus S, and there we go. Next is we're going to clean up the unnecessary objects located on the mesh. We want to filter everything to be hidden except the empties. And as you can see, you can use these empties if you want for constraints. Some animations make use of these empties, like parenting the weapon to the character, but in our case, we're just gonna delete all of them. Select all of them in the outliner and just press delete. The next is we're going to be resetting our armature's rotation by pressing Alt plus R. And we don't need the armature for now, so we can just hide it. We will also not be needing the face mask. This is used for Unity stencils, which Blender doesn't have obviously. And there we go, we have Pela unshaded. The next step is to import our light vectors. For this, I like to create a collection that is named Light Direction. We will then append from the blend file we just downloaded moments ago. You want to head onto node tree, and you want to look for the node group named Light Vectors. And as you can see, this is our head direction, and this is our light direction. For the next step, we want to have our head vector rotate along with the head bone. This is possible through a constraint. To do this, we want to enable back our armature. For the armature settings or the object settings, we want the viewport display to be in front, and then we want to display the bones as a wire. From here on, you want to find the head bone. It is a bit messy, so good luck. And seems like we found the head bone already, which is this small one. You can confirm by seeing if it's named head M. With your bone selected, you want to press Shift S and then cursor to selected. You want to go back to object mode, select your head empty, and then Shift S, selection to cursor. You can then have your cursor go back to the world origin by pressing Shift S and then going to the bottom left. The next thing you're going to do is head onto the object constraints of the head empty. There you'll see a child of constraint with no target. You'll want this constraint's target to be set to the character's armature. In our case, its name is Avatar Pela. You want to press on set inverse, and there we go. If we remove our head bone, now we will see the head vector rotating along with the head. We can now hide our armature again. The next step is to have our character's meshes recognize that these light vectors exist. To start, we'll select any mesh of our character. In this case, we'll select the hair. With your mesh selected, you'll want to head to its modifiers tab. You'll want to add a geometry nodes modifier. For the node group, you'll then use the light vectors node group that we just appended earlier. By default, all the parameters will be set, and the only thing we need to do is to output our attributes. For each attribute, we just want to copy the name on the left. For light there, we'll copy light there in camel case, head forward in camel case, and lastly, head up in camel case. The next thing we're going to do is we're going to select all the meshes of our character. You will want to control press the mesh you added the geometry nodes modifier to. In our case, it's hair. You will then click the drop down arrow here, click on copy to selected, and as you can see, all the meshes in our character now recognize that these light vectors exist. Now we can finally import our materials. Click File, Append, and then go back to Stellar Tune. Click on Material, then select everything except dot stroke. Let's head onto the Shading tab. Let's first replace the shader on the hair. Click the hair mesh, replace the hair material with Stellar Tune's hair, and then let's start importing the textures. For both these diffuse textures, we want to import the diffuse hair texture. For Pela, it's this one. Be sure to change the alpha mode of each texture from straight to channel pack. The next are these two light map textures. For all light map textures, their alpha modes should all be channel pack, and their color space should be non-color. For the hair warm shadow ramp, you want to select the node group, press tab, and then select the hair warm ramp. Do the same thing for the cool shadow ramp, and now you just have to do the same thing for the body and the weapon materials. For the body, some characters like Pela have stockings, In that case, you want to import the Stockings texture at the bottom. Just like the light map textures, the Stockings texture is supposed to be non-color. The body material also has a Stockings node group. You want to press on this node group, tab, and then just search for your Stockings texture. Some materials, like Pela's weapon screen, won't have a light map texture. In that case, you can just duplicate the main weapon's material and then apply emission on the settings. After the materials for both the body and weapon have been set up, let's then get to the face. Apply the face shader. And as you can see, it will be buggy. And the first thing we want to do, make sure screen space reflections is turned on. And then you want to drop down and also enable refraction. The next step is to import all our textures. For the expression map of the face, it's also meant to be non-color. The face material has a face light map node group. Make sure that the texture you're going to be applying here is also non-color. And as you can see, with all our textures applied, it still doesn't work. The thing is, you have to manually paint a set of vertex colors. This is for the see-through effect to work properly. I'm not sure of a way to achieve this effect without this extra step, but for now, we're gonna have to do it manually. To create this vertex color, you want to head to the Data tab. You want to expand color attributes. You want to press on Add Color Attribute. Keep everything as is. Click on OK. Make sure the original vertex colors are rendered by pressing this button. After this, you want to click on the Material Slots button. Go to the second slot and also apply the same material. Go back to the first slot. Go to Edit mode. Press on the Material slot. Press on Select. Make sure you're on the Faces mode. And then head onto Vertex Paint mode. You want to head onto Solid mode so you can visualize these vertex colors. You want to mask out the faces you selected earlier through this button here. Then you want to press on Paint, set vertex colors, and there you go. Go back to Object mode, go back to Rendered mode, and it should work almost. Now we have this problem. How do we fix this? It's simple as disconnecting the last node and then reconnecting it. And as you can see, now it works. If we enable the armature again and rotate our head, the face shading should work just fine. Now we're gonna make it look like in-game, and that's where the material files come into play. To view these JSON material files, you can just use any text editing program. In my case, I use Notepad++. For the face material, you only have to worry about the eye shadow color, the cool shadow color, and then the warm shadow color. To find the eye shadow color, you can just Ctrl F and then look for eye shadow with no spaces. These are the RGBA values. In most cases, you do not need to copy the A component. So in Blender, you want to head onto the eyeshadow color property, which is this one. And then for each value, you copy from the JSON file. For the warm shadow color, we want to search for shadow color. For the cool shadow color, you want to look for dark color. If all the values on dark color are 0.85, you can just copy the warm shadow color to the cool shadow color. Emission is usually turned on for the face. Pela does not have a nose line, but in the event that your character does have one, you can just look for the nose line power field and then the nose line color field. Moving on to the base shaders, let's first test if our character has an alpha map. If the alpha channel of your diffuse texture is all white, then that usually means that there's no transparency and that there's no emission. Let's move on to the specular settings. For each specular setting, there are 8 regions, and the property names in the JSON files are pretty self-explanatory. You should ignore all specular settings without any index, so you just copy starting from specular color 0 and so on. If your material has a stockings texture, then obviously you should enable stockings. For the stocking settings, you can just refer to the JSON file once more. For stockings color, you have stock color. For stockings darken color, you have stock dark color. For stockings rim width, you want to look at stock dark width. For stockings power, you want to look at the stock power property. For stock power 1, that is equivalent to stockings lighted width in Blender. For stockings lighted intensity, that is equal to stock SP in the material file. For stockings texture intensity, that is equal to stock roughness in the material file. For stockings thickness, that is equal to stock thickness. Once you've set up the materials for both the hair and the weapon, it's now time to move on to the outlines. To make the outlines, let's first make our outline materials. To edit the outline materials of our character, we can just add an extra unused material slot for each mesh of our character. The hair and the face outline materials do not use a light map texture. The same principle applies to the outline materials. You can refer to the outline colors in the JSON files. Now that we have the outline material set up, we can head to creating the geometry for it. Click File, Append, go to Node Tree, then append Stellar Tune Outlines GN. For each mesh, we'll be adding a new geometry nodes modifier, and then using that node group we just appended. These outlines will only properly work with a camera in the scene. So let's create a camera real quick. Then head onto the View tab, lock camera to view. In the Geometry Nodes modifier, click on the button next to Vertex Colors, then click on the empty field. Enter COL. For the camera field, set it to the camera you intend to use. For Screen Space Switch, I usually turn this on all the time, but this will only work if you have a camera set. For each outline mask, you want to make sure that you're applying it on the material where your mesh is on. In our case, it's base, and then base outlines. You can see, now it is working. Let's do it for the rest of the body. For the face, to remove these ugly outlines on the mouth, you want to set your depth offset to a higher value. I usually set mine to 6. And there we go, we have Pela fully set up in a blender with Stellar Tune. Everything works, and as you can see, she's looking very beautiful. There's a lot more things you can do with the shader. I've added a lot of options for artistic intent. For example, we can set our own shadow color. Just like how the game does it, you can also customize her expressions. If you want her to be shy, you can do that, or add some shadow to her face. Or you can also add some blush. There's a lot you can do with the shader, and I hope you guys create some cool stuff with it. If you have any problems, questions, or issues, you can hit me up on Discord. The username is Festivity. On Twitter, it's Festivizing. You can also join our Discord server with 5,000 members at discord.gg/omatsuri. And yeah, that's about it. See ya.